Today we're in the sports park in Columbia, Maryland, where we are installing a really unique solar system. It's a smaller system, but it has some powerful features and some smart engineering behind it that I want to walk you through today. This system uses a total of 41 solar modules installed across 3 separate park pavilions. Even though each pavilion is small, together they create a 24 kilowatt system that will generate more than half, about 53% of the park's annual electricity needs. Over its lifetime, this project is expected to save the county over $200,000 in energy cost. And with incentives like the federal tax credit, the payback period is only about 6 years. So even a smaller solar project can deliver huge long-term value. One thing I want to highlight is how the panels are mounted. These pavilions have standing seam metal roofs, so we're using S5 clamps. What's great about these clamps is that they grip directly onto the raised seams of the roof. That means no drilling, no penetrating the roof surface, and no compromising the structure. It's a very clean installation method that's both secure and non-evasive. S5 clamps. Each panel is paired with its own optimizer. What an optimizer does is pretty smart. Instead of the entire array working like one big chain, each panel works independently at its best performance. So if one panel gets a little shade or produces slightly less power for any reason, it doesn't bring down the rest of the system. Each optimizer adjusts the voltage and current, so the panel always gives us the maximum energy it can. Optimizers also give this system enhanced safety through something called rapid shutdown. In the event of an emergency like a fire, first responders can cut the voltage at the panel level almost instantly. Because these pavilions are separate from the main electrical building, we had to trench between them. Trenching simply means digging an underground pathway so we can safely run the electrical conduit between all 3 structures and bring everything back to the inverter. Putting the conduit underground protects the wiring from weather, vandalism, and landscaping equipment. And it keeps the park looking clean with no exposed cables. Once the trench is dug, we lay the conduit, backfill it, and pull the wires through to complete the electrical connection. Well, it started snowing. This is a great chance to answer one of the most common questions we get about solar. What happens when it snows on the panels? These panels are engineered to withstand heavy snow loads. They go through strict international testing for both pressure and weight, so the structure is completely fine in winter conditions like this. When snow does settle on the panels, it does temporarily reduce energy production simply because the sunlight can't reach the cells. But as soon as the sun comes back out, the panels naturally warm up and the snow glides right off. All of the power from the pavilions will come back to the inverter, which will be installed on the side of this building next to the emergency shutoff switch, which we already installed. The inverter takes the DC power the solar panels produce and converts it into AC power that the building can use. It also ties into real-time monitoring so the customer can track production and see how much solar energy they're generating each day. So that's a behind-the-scenes look at this solar pavilion project here in Columbia, Maryland. A small system, but packed with smart design and long-term savings. If you have any questions about how solar can work for your facility, or if you want Big Shine Energy to design one of these turnkey systems for you, feel free to reach out. Thanks for watching, and I'll see you in the next one.